This is the orbit of a dwarf planet named Sedna. It is wrong. It breaks Newton's laws. For a decade, astronomers dismissed it as an anomaly. But then they found another, and another, all pointing their silent, frozen fingers towards the same patch of empty black space. They are the breadcrumbs leading to the lair of a hidden giant. Imagine for a moment the grand cosmic clockwork of our solar system. For billions of years, it has turned with a breathtaking, almost divine precision. Every planet, every moon, every asteroid and comet, all engaged in an intricate gravitational ballet. Their movements predictable, elegant, governed by the ironclad laws of physics laid down by Newton himself. We humans, with our insatiable curiosity, have spent centuries mapping this dance, charting every pirouette, every stately orbit. We thought we knew it, this vast, familiar home. But then sometimes the universe whispers a secret. A beat is missed. A dancer steps wildly, impossibly out of line. And suddenly you realize there's someone new on the dance floor, a massive, unseen presence influencing the rhythm of worlds. For us, that whisper started in 2003, far beyond the familiar blue marble of Neptune. Out in the frigid, sun-drenched darkness, a team of astronomers led by Mike Brown, Chad Trujillo, and Scott Shepard stumbled upon something utterly baffling. They called it Sedna, named after the Inuit goddess of the sea, a cold, distant deity for a world so profoundly remote and icy. And Sedna's orbit. It was impossible. It was a cosmic anomaly that seemed to defy everything we thought we knew. A perfect solitary footprint found in the freshly fallen snow where no one should have been. Think about it this way. Every planet, every dwarf planet, every piece of space rock we've ever observed follows a path around the sun that makes sense. Ellipses, sure, some stretched out, some almost circular. But they all obey the gravitational pull of our star and the subtle nudges of its planetary entourage. Sedna, however, was different. Its orbit was so incredibly elongated, so stretched out into the deepest, coldest reaches of the void, that it would take anywhere from 10,000 spuds to 20,000 years to complete just one single solitary trip around the sun. To put that in perspective, while Neptune hugs the sun at about 30 astronomical units, an AYU being the distance from Earth to our sun, Sedna at its closest barely dips into the Kuiper belt. But at its furthest, it drifts hundreds of times farther than Neptune, an average of 400 to 800 astronomical units away. It was a loner, an outcast, traveling on a path that no known gravitational force, no combination of planets we understood, could fully explain. It was fundamentally wrong. For years, astronomers scratched their heads. It was a curiosity, a fascinating freak of nature, but many dismissed it as a one-off. An observational oddity, perhaps. A single isolated data point that, while intriguing, was easy enough to shunt aside as a random quirk of the cosmos. Just one lonely, silent finger pointing into the darkness, accusing an unseen force of gravitational harassment. It was a beautiful, bewildering puzzle, but without other pieces, it couldn't form a picture. But what if that finger wasn't so lonely after all? What if it wasn't just a quirk, but a crucial, undeniable clue? What if it was the first breadcrumb leading us down a cosmic rabbit hole? This is where our cosmic detective story truly begins. A narrative woven by the relentless curiosity of two brilliant minds at Caltech. Mike Brown, a planetary astronomer already infamous for his role in reclassifying Pluto. And let's be crystal clear from the outset, this hunt for Planet 9 is not about bringing Pluto back into the planetary fold. Planet 9, if it exists, would be a true giant, a monstrous world 5 to 10 times the mass of Earth, gravitationally dominating its entire vast region of space, unlike dear old Pluto. Brown teamed up with Konstantin Batygin, a theoretical astrophysicist whose specialty was the intricate dance of celestial mechanics, the complex gravitational choreography that holds our solar system together. Imagine them hunched over computer screens, surrounded by complex equations and endless data points, fueled by coffee and an unyielding passion for discovery. For years, more and more of these distant, icy worlds were being discovered, each one a tiny frozen pinprick of light in the vast cosmic ocean. And as they painstakingly charted the orbits of these trans-Neptunian objects, or TNOs, a chilling, undeniable pattern began to emerge. It wasn't just Sedna. One by one, these distant bodies started revealing something profoundly unsettling, something that defied the very randomness we'd come to expect from the outer reaches of our solar system. The moment of eureka wasn't a sudden flash, but a slow, creeping realization, a dawning understanding that built like a crescendo. It was like staring at a scattering of breadcrumbs on a forest floor, initially thinking them random, then slowly realizing they weren't scattered at all. They were deliberately, purposefully laid, leading in a specific, undeniable direction. What Brown and Batygin saw was that the most distant of these TNOs, 6 of them to be exact, weren't just on stretched-out elliptical orbits. Their orbits were aligned, not perfectly with mathematical precision, but significantly enough that the probability of it happening by pure chance was infinitesimally small, about 1 in 100, or a mere 0.07%. Think of it like this. Picture a bunch of clocks scattered randomly on a table. All their minute hands would point in different directions. But what if you walked into a room and every single clock's minute hand was pointing at, say, exactly 3 o'clock? You wouldn't assume it was a coincidence, would you? You'd assume someone or something had deliberately set them that way. That's what Brown and Batygin saw in the sky. These distant worlds, like frozen compass needles, were all pointing their silent, icy fingers toward the exact same patch of empty black space. This isn't just abstract data. It's a visual accusation. If you could see these orbits laid out before you like cosmic spaghetti on a vast, dark table, you'd notice something truly jarring. Instead of being randomly oriented, these particular noodles are all tilted in roughly the same direction, and their closest approaches to the sun, their perihelia, are all clustered together. It's as if an unseen hand is herding them, pushing them, bending their paths to its will, like a shepherd subtly guiding a flock. The solar system, that perfect clockwork, suddenly has a massive unseen gear out of sync, and it's pulling everything else slightly off kilter, creating these profound systematic distortions. This clustering, this collective crooked finger, wasn't just a curiosity. It was a piece of undeniable physical evidence. It implied a hidden presence, demanding an explanation. These weren't just random anomalies anymore. They were the undeniable gravitational footprints of something massive, dark, and unseen, stomping through the outer reaches of our cosmic backyard. So, what could cause such a profound systemic alignment? Brown and Batygin's mathematical models and computer simulations, run countless times to rule out every other possibility, pointed to one compelling answer: a hidden planet, a true giant, unlike anything we've found in the outer solar system since Neptune itself. A world so incredibly far out that its gravitational tug could reach across hundreds of astronomical units, subtly but persistently shaping the paths of these distant icy bodies. This hypothetical world, now famously dubbed Planet 9, is believed to be what astronomers call a super-Earth, a type of planet common throughout our galaxy, but mysteriously, conspicuously absent from our own inner solar system. Imagine a world 5 to 10 times the mass of our Earth, yet shrouded in perpetual twilight, reflecting so little sunlight that it has remained a ghost, even to our most powerful telescopes. A truly massive, ice-shrouded giant, silently herding a distant flock of frozen worlds. Now, if this sounds like something ripped straight from the pages of a science fiction novel, it's actually a classic detective story that has played out before in the annals of astronomy. Remember Neptune? In the mid-19th century, astronomers noticed that Uranus, a relatively new discovery itself, wasn't quite following its predicted path. It wobbled, it deviated, and based on these subtle perturbations, brilliant mathematicians like Urbain Le Verrier and John Couch Adams independently calculated where an unseen planet should be. Pulling on Uranus, they pointed their telescopes and boom, there was Neptune, exactly where the math said it would be. It was a triumph of gravitational physics, a testament to the power of observation and calculation, a perfect example of unseen evidence leading to profound discovery. But there's also a cautionary tale in this very history, a reminder of scientific humility. For decades, astronomers also hunted for a planet called Vulcan, which was thought to orbit inside Mercury's path, explaining oddities in its orbit. That planet was never found, and eventually Einstein's revolutionary theory of general relativity provided the true, elegant explanation for Mercury's peculiar wobble. So, are we hunting a new Neptune, a hidden giant waiting to be unveiled, a monumental addition to our cosmic neighborhood? Or are we chasing a ghost that will ultimately be explained by some new, unforeseen twist in our understanding of the universe, a new Einstein waiting to rewrite the rules? This is the heart of the mystery, an undeniable pattern in the cosmic dance, a collective crooked finger pointing into the void. It's a puzzle, pieces from the very edge of our solar system, all locking together to form the outline of something immense, something dark, something that shouldn't be there, but almost certainly is. The evidence for Mike Brown and Konstantin Batygin is overwhelming. The breadcrumbs are laid, the trail is hot, and the hunt for this hidden giant, this phantom world lurking in our own backyard, has begun. And it's a hunt that will push the very limits of human ingenuity and our most powerful instruments, peering into the deepest, darkest corners of our home. It began, as so many great cosmic mysteries do, with a single perplexing anomaly. Imagine for a moment the vast, cold, inky blackness that lies beyond Neptune, a region we call the Kuiper Belt. Here, countless icy bodies drift in an eternal waltz around our sun. But then, in 2003, astronomers Chad Trujillo and Mike Brown made a discovery that would shatter our understanding of this distant realm, a dwarf planet named Sedna. Now, Sedna wasn't just another icy rock. Its orbit, you see, was downright wrong. It was so elongated, so stretched out, that it took a staggering 11,400 years to make just one trip around the sun. And more than that, its closest approach to the sun was still incredibly far out, almost 76 times the Earth-Sun distance, meaning it never truly warms up. It was, in essence, a world that should not exist, according to the known gravitational rules of our solar system. For nearly a decade, Sedna was largely dismissed as an oddity, a cosmic freak of nature, a single data point without context. Astronomers shrugged, filed it away, and moved on. It was an anomaly after all, just one. What could one rogue orbit really tell us? But as the years passed, something began to shift. More discoveries were made, and with each new icy world found hurtling through the outer darkness, a pattern, subtle at first, began to emerge. These distant objects, sometimes called extreme trans-Neptunian objects, or ETNOs, weren't just randomly scattered. They were telling a story. Enter Mike Brown, the seasoned field investigator of our cosmic detective story. You might know his name. He's the very same astronomer who, years earlier, played a pivotal role in the reclassification of Pluto from a full-fledged planet to a dwarf planet. That was a big deal, a real shakeup in our understanding of what constitutes a planet. And it's crucial to understand this now. Brown isn't on a crusade to reinstate Pluto, nor is he looking for another dwarf planet. This time, he's hunting for something far grander, a true giant, a world that would undoubtedly earn its planetary stripes, a world perhaps 5 to 10 times the mass of Earth. He was the one who initially noticed the peculiar nature of Sedna and similar objects. He was finding the clues, these bizarre, stretched-out orbits, but finding the clues is only half the battle. You also need someone brilliant enough to build the criminal profile, to connect those disparate clues into a coherent picture. That's where Konstantin Batygin comes in. He's the brilliant theorist, the mathematical wizard who can look at complex data and see the hidden forces at play. Together, Brown and Batygin form an unlikely yet incredibly potent team at Caltech. For years, even Mike Brown himself was skeptical. He'd seen Planet X theories come and go, most of them dissolving under closer scrutiny. The idea of a ninth major planet lurking unseen in our own backyard felt almost too romantic, too reminiscent of old-school astronomy. But the data kept nagging at him, kept whispering its secrets from the edge of the solar system. Then came the eureka moment. Picture this. It's 2014. Brown and Batygin are sitting together, their screens filled with the chaotic lines representing the orbits of these distant, icy worlds. They had, by this point, identified 6 of the most extreme objects beyond Neptune, including Sedna. What they noticed was truly astonishing. If you were to plot these orbits, not just as individual paths, but as a collective, a startling pattern leaped out. Imagine a group of compasses, each one spinning wildly, pointing in random directions. That's what you might expect from objects so far out, so seemingly uninfluenced by the inner solar system. But what Brown and Batygin saw was completely different. It was as if all 6 of these cosmic compasses were silently, almost conspiratorially, pointing their frozen fingers in the exact same direction in space. Not only were their elliptical paths all clustered, but they were also tilted in the same way, like a group of synchronized swimmers performing a complex maneuver. It was like seeing a giant arrow pointing to something. Batygin later described it. A complete shock. This wasn't just a coincidence. This wasn't random chance. The statistical probability of these 6 objects aligning in such a precise way, purely by accident, was astronomically small, about 1 in 100, or a mere 0.07%. To put that into perspective, you'd have a better chance of winning the lottery multiple times in a row. This was a pattern too strong, too undeniable, to ignore. It was the moment the scattered lines on their screens transformed into a coherent, undeniable pattern. It was the moment the faint, icy whispers from the outer solar system became a chorus, all singing the same tune. There is something out here. These weren't just scattered breadcrumbs. They were a meticulously laid trail, leading directly to the lair of a hidden giant. What kind of giant, you ask? Well, their mathematical models and computer simulations painted a compelling picture. They suggested that the gravitational influence of a massive, unseen planet was literally shepherding these distant objects, corralling their orbits, tilting them, and pulling them into this strange alignment. Think of it like a massive, invisible ship moving through the ocean, and the smaller boats in its wake are all subtly nudged and organized by its passage. That's the kind of gravitational shepherding we're talking about here. This wasn't just a wild guess either. The history of planetary discovery is filled with such moments. Remember Neptune? It wasn't first spotted through a telescope. It was mathematically predicted in 1846 by Urbain Leverrier and John Couch Adams, who noticed inexplicable wobbles in Uranus's orbit. They reasoned that only the gravitational pull of another unseen planet could account for those perturbations. And when astronomers pointed their telescopes exactly where the math said Neptune should be, there it was. Brown and Batygin were following a similar time-honored scientific tradition. The perturbations they were seeing weren't in the orbits of giant planets like Uranus, but in the most distant, fragile, icy worlds in our solar system. And the implications were profound. Their models suggested this unseen world, provisionally dubbed Planet 9, would be a super-Earth, a type of planet common throughout our galaxy, but conspicuously absent from our own solar system. It would be anywhere from 5 to 10 the mass of Earth, large enough to dominate its region of space, far beyond any dwarf planet. Its orbit would be truly immense, taking between 10,000 and 20,000 years to complete just one circuit around the Sun. And it would spend most of its impossibly long year at an average distance of 400 to 800 astronomical units from the Sun. That's hundreds of times farther than Earth, and many times farther than even Neptune, which is already 30 AU out. This colossal distance is precisely why it's remained hidden for so long. It's a world of perpetual twilight, reflecting precious little sunlight, a truly ghostly presence in our cosmic backyard. The elegance of their hypothesis didn't stop there. Not only did it explain the bizarre clustering of the 6 main etnos, but it also made a bold prediction. There should be another population of objects moving in orbits perpendicular to the main plane of the solar system, also influenced by Planet 9's gravitational tug. And sure enough, after they published their initial findings, astronomers found evidence of such objects, further strengthening their case. Of course, in science, there's always skepticism, and rightly so. Some scientists have proposed alternative explanations, like the idea that the observed clustering might just be an observational bias, that we only find the objects that are easiest to see, and that skews our perception of their orbits. Or perhaps, they suggest, the collective gravity of a massive undiscovered disk of smaller icy bodies could be doing the shepherding, rather than a single large planet. These are valid points, part of the rigorous back and forth of scientific discovery. But for Brown and Batygin, the evidence was too compelling, the statistical improbability too stark. They had found the fingerprints, the footprints, the undeniable breadcrumbs, and they believe, with every fiber of their scientific being, that these clues point to one thing: a massive hidden world, a true planet, waiting to be found. The hunt was on, not for a theoretical construct, but for a tangible physical world, a new addition to our family of planets. And the stakes, for our understanding of the solar system and our place within it, couldn't be higher. Before we plunge headfirst into the unknown, before we chase this phantom through the dark, let's take a moment. Let's remember the solar system we do know, the one that cradles our existence, the cosmic home we've charted for centuries. Close your eyes for a moment and picture it. Imagine, if you will, standing at the very heart of our solar system, the sun a brilliant, searing diamond at your back, its light reaching out, an invisible hand guiding everything around you. From this impossible vantage point, you witness a dance, a cosmic ballet of unparalleled precision and breathtaking scale. This isn't just a collection of rocks and gas. It's a living, breathing, perfect machine, a great, silent clockwork, meticulously crafted over billions of years. Closer in, Mercury, A tiny scarred cannonball zips around the sun at an astonishing pace, a blur against the fiery backdrop. Then comes Venus, shrouded in perpetual cloud, a world of blistering heat and crushing atmosphere. Yet it too follows an unyielding path, a slow, majestic pirouette that defines its year. And then, our home, Earth. You can almost feel its gentle, rhythmic spin, the familiar tilt that brings us seasons, the predictable journey around the sun that marks the passage of our lives. It's a blue marble, vibrant with life, a constant, comforting presence in this grand design. Beyond us, Mars, the red planet, rolls along its elliptical track, a more distant cousin, but still an integral part of this inner circle, its path as certain as the rising tide. These inner worlds, quick and agile, are like the fast-ticking gears in a finely crafted watch, each revolution perfectly timed, each movement contributing to the overall harmony. They are swift, but their paths are never chaotic. They don't collide. They don't veer off course. They are bound by an invisible, unbreakable thread, a celestial leash that keeps them forever circling their parent star. And then, you journey outward, past the asteroid belt, that vast scattered ring of rocky debris, each fragment, large or small, also obeying the gravitational imperative, a chaotic yet ordered ribbon, separating the inner warmth from the outer chill. Beyond this cosmic boundary lie the giants, the true behemoths of our solar system. First, Jupiter, a swirling tempest of a world so massive it could swallow all the other planets whole. Twice over, it doesn't rush. It moves with a ponderous, regal grace, its colossal mass dictating a grand, slow waltz around the sun, a journey that takes nearly 12 Earth years. You can almost feel its immense gravitational presence, a silent shepherd guiding its own retinue of moons, a miniature clockwork within the larger one. Then comes Saturn, the undisputed jewel of the night sky, encircled by its breathtaking rings, a masterpiece of cosmic art. Its orbit is even slower, a more deliberate sweep through the void, a full revolution taking almost 30 years. Farther still, Uranus, a pale blue orb, rolls on its side, a strange, beautiful anomaly. Yet even its peculiar tilt doesn't disrupt the clockwork. It continues its stately march, taking an astonishing 84 Earth years to complete a single circuit. And finally, Neptune, the outermost known giant, a deep blue gem, lost in the frigid depths of space, moves with an almost imperceptible crawl, its years stretching to a staggering 165 Earth years. Each of these worlds, from the smallest and swiftest to the largest and most languid, is a gear in the grandest machine you can possibly conceive. They are all linked, not by physical rods or levers, but by the invisible, powerful hand of gravity. It is the fundamental force, the universal glue, that binds our solar system together, orchestrating this magnificent dance. Isaac Newton, centuries ago, gave us the language to understand this cosmic choreography. His laws of motion and universal gravitation laying bare the elegant mathematics behind the celestial ballet. It's a system so perfectly balanced, so meticulously ordered, that we can predict its movements with breathtaking accuracy, down to the second. We know when eclipses will darken our skies, when comets will return from their long slumber, when planets will align in rare conjunctions. This predictability isn't just a scientific marvel, it's the very foundation of our existence. It's why seasons come and go, why days turn into nights, why life on Earth has found a stable, nurturing home. For millennia, humanity has looked to the heavens and found not chaos, but profound order, a celestial rhythm that has guided our calendars, our navigation, our very understanding of time. Think about the comfort, the deep-seated reassurance that comes from this cosmic reliability. Every sunrise, every sunset, every full moon painting the night sky, every star that appears exactly where it should be. These are all testaments to the great silent clockwork working flawlessly. The silent aspect of this clockwork is perhaps its most profound. In the vacuum of space, no sound carries. There are no creaking gears, no grinding cogs, no audible hum of immense power. It is a dance performed in utter, profound silence, yet the forces at play are so immense, so utterly dominant, that they shape entire worlds. For us, this grand, silent clockwork is home. It's the familiar tapestry of stars and planets we've come to know, the framework within which all our stories unfold. It's a universe that, at least in our immediate vicinity, makes sense. A testament to the elegant laws of physics that govern everything from the smallest atom to the largest galaxy. It is a system of such remarkable stability and order that it feels almost eternal, an unshakable truth etched across the fabric of space-time. But even the most perfect clockwork can harbor a secret. What if, far beyond the familiar sweep of Neptune, past the known boundaries of this perfectly ordered system, there's another gear, a massive, dark, unacknowledged component, turning slowly, silently out of sync with everything we thought we understood? What if, in the profound order of our cosmic home, there's a hidden source of chaos, a gravitational ghost pulling at the threads of this magnificent tapestry, leaving clues for those brave enough to look? What if the universe, even in our own backyard, is stranger, more mysterious, and more wonderfully complex than we've ever dared to imagine? What if this perfect clockwork, for all its majestic harmony, is missing a piece, or perhaps hiding one? And what if that missing piece is pulling the strings, whispering secrets to the icy worlds at the very edge of our known universe? You know, for all the grand, sweeping narratives we tell about the cosmos, sometimes the biggest mysteries are hiding right here, in our own backyard. And sometimes the hunt for those mysteries isn't just about what's out there, but about what we've learned from the hunts of the past. Because this isn't the first time we've gone chasing a ghost in our solar system. Not by a long shot. Imagine for a moment the year 1846. The scientific world is buzzing with a celestial puzzle. Astronomers have been meticulously charting the path of Uranus, a giant ice world discovered decades earlier. But something is off. Uranus isn't following the rules. Its orbit, predicted with Newton's beautiful, elegant laws of gravity, is subtly, stubbornly wrong. It's wobbling just a little, speeding up here, slowing down there, like an invisible hand is tugging at it, pulling it slightly off course. This wasn't just a minor annoyance for the astronomers of the 19th century. It was a profound challenge to their understanding of the universe. Newton's laws were the bedrock of celestial mechanics, the very foundation of how they understood the heavens. If Uranus was breaking those laws, then something fundamental was missing. Enter two brilliant minds, thousands of miles apart, working independently. Urbain Le Verrier in France and John Couch Adams in England. These were men who didn't just look up at the stars. They saw the universe as a grand, intricate clockwork, and they believed that every anomaly had a cause. They looked at Uranus's errant path, not as a mistake in Newton's physics, but as a set of cosmic footprints. Footprints left by something unseen, something massive, pulling at Uranus with its gravitational might. They started with the wrongness of Uranus's orbit, and then they did something truly extraordinary. They used pure mathematics, paper and pen, to work backward. They calculated with incredible precision where an unseen planet would have to be, how big it would have to be, and what its orbit would look like. To explain those tiny, persistent wobbles, they were, in essence, following the ghost's trail, predicting its very lair before anyone had ever laid eyes on it. And then, On September 23, 1846, at the Berlin Observatory, Johann Galle received Leverrier's predictions. He pointed his telescope to the exact patch of sky Leverrier had specified, and there it was, a new planet, a magnificent blue giant, Neptune. It was a triumph of prediction over observation, a testament to the power of mathematics to reveal hidden truths. It showed humanity that our solar system held secrets, and that sometimes the best way to find them was to first feel their presence through the subtle dance of gravity. This story, this incredible validation of scientific reasoning, is the ghost we want to find again. It's the blueprint for how Mike Brown and Konstantin Batygin are trying to find Planet 9 today. They are not looking at Uranus. They're looking at the bizarre, clustered orbits of icy dwarf planets, like Sedna, out past Neptune, and seeing the same kind of subtle, persistent tug, the same kind of wrongness that points to an unseen gravitational puppeteer. The historical precedent of Neptune gives their modern hunt immense credibility, a powerful echo from the past. It says, "We've done this before. We can do it again." But every good detective story has a twist, right? Because while the hunt for Neptune was a glorious success, history also holds a different kind of ghost story, a cautionary tale. The hunt for a phantom planet named Vulcan. This story takes us even closer to the sun, to the innermost planet, Mercury. For decades after Neptune's discovery, astronomers noticed something else was off. Mercury, like Uranus, wasn't quite following its predicted path. Its perihelion, the point in its orbit closest to the Sun, was precessing or shifting by a tiny, inexplicable amount each century. Again, Newton's laws, while largely accurate, just couldn't quite account for it all. So, astronomers, emboldened by the success with Neptune, did what seemed logical. They hypothesized another unseen planet, a small, rocky world, much closer to the Sun than Mercury, whose gravitational pull would explain the tiny discrepancy. They even named it Vulcan. The hunt was on. People searched for decades. They pointed telescopes towards the Sun, hoping to catch a glimpse of this elusive inner world. There were even supposed sightings, fleeting blips that were later dismissed as sunspots or observational errors. The idea of Vulcan became a kind of scientific obsession, a ghost everyone believed in because the math seemed to demand it. But Vulcan was never found, because sometimes the wrongness isn't a sign of something missing, but a sign that our understanding of the rules themselves needs to change. It took a genius named Albert Einstein and his revolutionary theory of general relativity to finally lay the ghost of Vulcan to rest. Einstein's theory, which describes gravity not as a force, but as the curvature of space-time caused by mass and energy, perfectly explained Mercury's anomalous orbit without the need for any hidden planet. The wrongness wasn't caused by an unseen object. It was caused by our incomplete understanding of the universe's fundamental laws. And that, my friends, is the critical question hanging over the modern hunt for Planet 9. Are we, like Leverrier and Adams, following the real gravitational footprints of a hidden giant destined to find a new Neptune? Or are we, like the eager astronomers chasing Vulcan, misinterpreting the evidence, chasing a phantom that will ultimately be explained by a deeper, more profound understanding of physics we haven't quite grasped yet? The stakes couldn't be higher. If Mike Brown and Konstantin Batygin are right, if their mathematical models and simulations of those strange clustered orbits are truly pointing to a massive unseen world, then a new planet awaits discovery. A true giant, perhaps 5 to 10 times the mass of Earth, lurking in the cold, dark reaches of our solar system, waiting to be added to our cosmic map. This isn't about reinstating Pluto, which is a dwarf planet, roughly 5,000 times less massive than the hypothesized Planet 9. This is about finding a world that would reshape our understanding of how our solar system formed and evolved. But if they are wrong, if the clustering of the distant icy objects is merely an observational bias, a trick of the light, or if it's explained by some entirely new gravitational phenomenon, then Planet 9 will join Vulcan in the annals of well-intentioned, but ultimately mistaken scientific pursuits. This duality, the triumph of Neptune, the phantom of Vulcan, is the historical backdrop against which the current hunt for Planet 9 unfolds. It's a story of human ingenuity, of relentless curiosity, and of the sometimes humbling, sometimes exhilarating process of scientific discovery. It's a reminder that sometimes the universe holds secrets we can find by just looking harder, and sometimes it demands we look at the very fabric of reality in an entirely new way. The question isn't just if Planet 9 is out there, but what kind of discovery it will be. Will it be the validation of a brilliant prediction? A new Neptune revealing itself to our powerful telescopes? Or will it be a new Vulcan, forcing us to rethink the very rules of the cosmic game? The breadcrumbs are there, the footprints are clear, but are they leading us to a hidden giant, or to a new frontier of physics we can barely imagine? The hunt is on, and the ghosts of hunts past whisper their lessons, both triumphant and cautionary, across the vast, silent expanse of space. The breadcrumbs are there, the footprints are clear, but are they leading us to a hidden giant, or to a new frontier of physics we can barely imagine? The hunt is on, and the ghosts of hunts past whisper their lessons, both triumphant and cautionary, across the vast, silent expanse of space. Now, imagine yourself standing at the very edge of our solar system, beyond the familiar dance of planets, past the icy realm of Neptune, and out into a darkness so profound it would swallow every star you've ever known. It's a place where the sun is just another distant star, a bright pinprick among billions. This is the hunting ground for Planet 9, a ghost in our cosmic backyard, and finding it is like trying to hear a whisper in the middle of a hurricane. That hurricane isn't just a metaphor for chaos. It's the overwhelming, dazzling noise of the cosmos itself. Think about it. Billions of stars, each one a sun, blazing across the night sky. Then there are entire galaxies, swirling maelstroms of light, each containing billions more stars. And closer to home, countless asteroids, comets, and other icy bodies, all reflecting some tiny sliver of sunlight. All of it is clamoring for our attention, a cacophony of light that can easily drown out the faint, hopeful signal we're listening for, the whisper we're straining to hear. That's the reflected sunlight from a potential planet, maybe 5 to 10 times the mass of Earth, lurking hundreds of astronomical units away. That's hundreds of times farther from the sun than our own blue marble. To put that in perspective, Neptune, the outermost known major planet, sits at about 30 OU. Planet 9 is hypothesized to be at an average distance of 400 to 800 AU. That means any light it reflects back to us is incredibly, fantastically dim. We're talking about an object that could be 160,000 times fainter than Neptune, a mere speck of dust in an ocean of night. And it's cold, so cold that it barely emits any heat of its own. It's a shadow, barely illuminated, moving agonizingly slowly against the backdrop of an infinite, glittering universe. So, how do you even begin to find something like that? It's a challenge that pushes the very limits of human ingenuity and our most advanced technology. For years, astronomers like Mike Brown and Konstantin Batygin, the theoretical architects of Planet 9, have worked tirelessly not just on the math that predicts its existence, but on the meticulous, painstaking process of figuring out how to see it. Their work is a testament to what we can achieve When we combine brilliant minds with powerful tools, the search isn't about pointing a telescope at a specific spot and hoping to catch a glimpse. It's a systematic, exhaustive sweep of the sky, looking for the faintest flicker, the merest hint of movement. Remember, everything in our solar system orbits the sun. Even an incredibly distant, slow-moving object, like Planet 9, would shift its position ever so slightly against the seemingly static background of distant stars over days, weeks, or months. That teeny, almost imperceptible shift is the clue. That's the whisper in the hurricane. Astronomers use some of the most powerful telescopes on Earth, instruments that are essentially giant light buckets, designed to gather every single photon they can. They take image after image of the same patches of sky, then painstakingly compare them, often using sophisticated computer algorithms to identify anything that moves. But with billions of stars and countless faint objects, this is a monumental task. It's like searching for a single specific grain of sand on every beach in the world, in the dark. With only a tiny flashlight, enter the hero of our story, the game-changing character in this cosmic detective drama, the Vera C. Rubin Observatory. This isn't just another telescope. It's a revolution. Imagine an instrument so powerful, so efficient, that it can photograph the entire visible southern sky every few nights. That's its superpower. Expected to begin science operations in 2025, the Rubin Observatory, located high in the Chilean Andes, is poised to be the final arbiter in the hunt for Planet 9. Let's talk about what makes the Rubin Observatory so special. At its heart is an 8.4-meter primary mirror. But the real marvel is its camera, the Legacy Survey of Space and Time camera, or LSST cam. This isn't your smartphone camera. This is the largest digital camera ever built for astronomy. It's a 3-ton behemoth, roughly the size of a small car, packing an incredible 3.2 gigapixels of resolution. Think about that for a second. That's enough detail to see a golf ball from 15 miles away. This camera isn't just big. It's designed for speed and breadth. Most telescopes are like snipers, designed to zoom in on tiny, specific targets with incredible precision. The Rubin Observatory is different. It's a wide-field surveyor, more like a cosmic floodlight. It takes incredibly wide, deep images of the sky, capturing vast swaths of it in a single shot. Then it does it again, and again, night after night. By repeatedly imaging the same areas, it builds up a detailed, time-lapse movie of the sky. This is crucial for finding Planet 9. Because Planet 9 is so faint and so far away, we won't just see it as a static point of light. We'll detect it by its movement. Over the course of a few nights, or even a few hours, a nearby object in our solar system will appear to shift slightly against the distant, fixed background of stars and galaxies. The Rubin Observatory's ability to constantly rescan the sky means it can detect these subtle shifts, these tiny trails of movement that would be completely missed by traditional narrower field telescopes. It's designed to spot the moving speck of dust in the ocean of night. The data it will generate is almost unimaginable. An estimated 20 terabytes every single night. That's more data than the Library of Congress holds in its entire collection every single night. Sifting through this deluge of information will require cutting-edge artificial intelligence and supercomputers, algorithms specifically trained to identify those faint, slow-moving objects that are the hallmarks of a distant, hidden world. When Brown and Batygin first presented their hypothesis, it was based on the statistical improbability of several distant icy objects, known as extreme trans-Neptunian objects, ETNOs, having orbits that were all clustered and tilted in the same way. The odds of this happening randomly are roughly 1 in 100, or a mere 0.07%. Their mathematical models didn't just explain these known anomalies, they also predicted the existence of other objects with orbits perpendicular to the plane of the solar system. And guess what? Astronomers later found those too. Further bolstering the case, the Vera C. Rubin Observatory is equipped to not only find more of these clustered objects, but, more importantly, to potentially spot Planet 9 itself. If it's out there, reflecting even the tiniest amount of sunlight, the Rubin will capture its ghostly movement across the sky. This isn't some distant hope. It's an imminent possibility. Within a year or two of its full operation, we could have the definitive answer. The hunt, while incredibly difficult and spanning years of dedicated effort, is now entering its most hopeful and final chapter. This isn't just about finding a new planet. It's about understanding the very architecture of our solar system, how it formed, and how it evolved. If Planet 9 is a super-Earth, a planet larger than Earth, but smaller than Neptune, it would be a missing link, as this type of planet is the most common in our galaxy, yet conspicuously absent from our own inner solar system. Its discovery would rewrite textbooks and challenge our assumptions about what's possible in our cosmic neighborhood. So, as the Rubin Observatory began its tireless watch, sweeping the vast southern skies, we stand on the precipice of discovery. The scientific community is holding its breath. Mike Brown and Konstantin Batygin are undoubtedly feeling a blend of anticipation and anxiety. And we, the curious observers, are all waiting for that whisper to finally break through the cosmic hurricane. Will it be a clear, undeniable signal, confirming the existence of a hidden giant? Or will the silence persist, pushing us to ask even deeper, more profound questions about the universe we thought we knew? The answer, incredibly, is closer than it has ever been. The answer, incredibly, is closer than it has ever been. But to truly appreciate the audacity of this hunt, to grasp what it means to search for a hidden world so far out, you first have to understand the sheer mind-bending scale of the emptiness we're talking about. Forget the neat, tidy diagrams you saw in school, with planets lined up like beads on a string. That's not our solar system. Not really. Our solar system is mostly nothing. And that nothing stretches out, cold and dark, for distances that make your brain ache just trying to imagine them. So let's take a moment. Let's really feel that scale. Close your eyes for a second, or just let your gaze drift. You're here, on Earth, our vibrant living world, bathed in the warmth of our star. Light from the sun takes a comfortable 8 minutes to reach us. We've got our moon, a familiar companion, just a few light seconds away. The inner planets, Mercury, Venus, Mars, they feel close, don't they? Mars, our nearest planetary neighbor, is a mere hop, skip, and a jump, a few light minutes when it's closest. We send rovers there. We dream of sending people. It feels like our backyard. But then, the distances start to expand. You push past the asteroid belt, a rocky debris field that's less a crowded highway and more a vast, empty expanse with scattered cosmic dust. And then, you encounter the giants. First, Jupiter. Imagine a world so immense that all the other planets in our solar system could fit inside it. It's a behemoth, a swirling vortex of gas and storms, hundreds of millions of miles from the sun. Light takes over half an hour to reach it. That's a journey. You could start a podcast and listen to a few episodes before the sun's light even touched Jupiter's cloud tops. Keep going. We drift further out, past Jupiter's powerful magnetic field, past its dozens of moons. Next up is Saturn, majestic with its iconic rings, a breathtaking jewel in the cosmic black. Even from here, the sun is noticeably smaller, a brilliant pearl. but already less dominant. Saturn is nearly 1 billion miles from the Sun. Light takes well over an hour to get there. Think about that. By the time you see the sunlight reflecting off Saturn's rings, that light left the Sun before you even finished your morning coffee. The air here is thin, the silence absolute, and the cold is starting to bite, even if you're just imagining it. And we're not even halfway to the known edge of our solar system yet. Beyond Saturn, the chill deepens, the light dims further. We passed Uranus, a sleepy blue-green ice giant, tilted on its side, rolling through space like a cosmic bowling ball. It's roughly 1.8 billion miles from the Sun. Sunlight, traveling at 186 miles per second, takes nearly 3 hours to reach Uranus. Imagine a conversation with someone on Uranus. You say something, then wait 6 hours for their reply. This isn't just distance. It's a profound separation, a chasm of time and space. And then, Neptune, the outermost known planet in our solar system. A deep blue world, whipped by supersonic winds, nearly 2.8 billion miles from the Sun. Here, the Sun is just a very bright star, not a life-giving furnace. Sunlight takes over 4 hours to make the journey. Think about the Voyager 2 spacecraft, which zipped past Neptune in 1989. The signals it sent back to Earth, even traveling at the speed of light, took over 4 hours to arrive. It's like listening to an echo from a different lifetime. This is the last known giant, the last world we've thoroughly explored in our own neighborhood. And it sits at roughly 30 astronomical units from the Sun, 30 times the distance from the Earth to the Sun. But for Planet 9, we have to go so much further. Beyond Neptune, the true emptiness begins. You leave behind the comforting, if vast, neighborhood of the gas giants, and you plunge into the Kuiper Belt. Now, when we say belt, don't picture something dense and crowded, like an asteroid belt. Think of it more like a diffuse, icy halo, a donut-shaped region of space filled with countless frozen remnants from the early solar system. These are the dwarf planets, like Pluto and the mysterious Sedna, the very breadcrumbs that led Mike Brown and Konstantin Batygin to their extraordinary conclusion. This is where the known ends and the truly unknown begins. This is a region so vast, so sparsely populated, that even with our most powerful telescopes, finding anything here is like trying to spot a single grain of sand on every beach on Earth, all at once. The Kuiper Belt itself stretches for hundreds of AU, from about 30 AU all the way out to 50 AU, maybe even further. It's not a quick trip. If you were traveling at the speed of light, it would take you days, even weeks, just to cross this icy expanse. And Planet 9? If it exists, it's not even in the Kuiper Belt proper. It's far beyond it. We're talking about a world that could be orbiting at an average distance of 400 to 800 AU from the Sun. Let that sink in. If Neptune is 30 AU, then Planet 9 is potentially 13 to 26 times further out than Neptune. Light from the Sun would take days, maybe even weeks, to reach Planet 9, and then days or weeks more to bounce off it and travel back to our telescopes here on Earth. That's a round trip of months for a single photon. In this profound, silent void, the Sun is just another star, albeit the brightest one, but certainly not a warming orb. It would be a distant, brilliant point of light, no more. The temperatures plummet to hundreds of degrees below zero, a cold that would instantly freeze any exposed liquid, a cold that permeates the very fabric of space. This is a realm of eternal twilight, where shadows stretch infinitely, and the only light comes from the faint gleam of distant galaxies, or the occasional impossibly bright flash of a supernova, light years away. This is the hunting ground. This is the lair of the hidden giant, a place so far out, so dark, so cold that it defies easy comprehension. And this is why the hunt for Planet 9 isn't just about looking through a telescope. It's about an act of profound patience, of ingenious deduction, and of pushing the very limits of our technology to peer into the deepest, darkest corners of our own home. Because out here, a world estimated to be 5 to 10 times the mass of Earth, a true super-Earth, could be lurking, reflecting so little light that it's an astounding 160,000 times dimmer than Neptune. It's effectively a ghost, a gravitational whisper in a cosmic hurricane, unseen, unheard, but undeniably felt by the distant, icy breadcrumbs it leaves in its wake. The scale of this emptiness isn't just a number, it's a feeling of isolation, of wonder, and of the sheer incredible audacity of the human mind to even conceive of a hidden giant out there, pulling the strings of distant worlds in a place we can barely even imagine. It makes you feel incredibly small, doesn't it? But it also makes you realize the boundless capacity of our curiosity, the relentless drive to map out every last corner of our cosmic home, even if that corner is a vast, cold, and utterly empty expanse. The emptiness is immense, but our desire to fill it with knowledge is even greater. That emptiness is immense, but our desire to fill it with knowledge is even greater. But hold on a minute. A good detective story, and certainly good science, isn't just about the prosecution laying out their case. It also needs a defense. Because for every compelling piece of evidence that Mike Brown and Konstantin Batygin have assembled, there are other brilliant minds in the cosmos-gazing world who look at the exact same data and offer a very different story. They see the same strange clustered orbits, the same inexplicable tilts and alignments, but they don't see a hidden giant pulling the strings. Instead, they see something far more subtle, and in its own way, just as profound. The ghost of our own limitations. This is the case for the defense, and it's where we get to truly grapple with the messy, exhilarating, and often contentious heart of scientific discovery. Because science isn't a straight, unwavering line to truth. It's a rigorous debate, a constant back and forth, where hypotheses are forged in the fires of evidence, only to be challenged, tested, and sometimes respectfully dismantled by new insights. And in the hunt for Planet 9, the strongest counter-argument comes down to two simple words: observational bias. Imagine, if you will, that you're an expert deep-sea diver, tasked with finding a rare glowing fish. You have a powerful spotlight, but it only illuminates a small cone directly in front of you. You spend years diving, always pointing your light in the same general direction, or perhaps focusing on areas where the water is clearer or where the currents are more predictable. Over time, you start noticing something odd. All the glowing fish you find seem to be clustered in very specific parts of the ocean. They're always in the same kind of watery patches, following similar paths. You might conclude that these fish are being herded by some unseen force, or that they naturally prefer these specific zones. But what if the truth is far simpler? What if you're only finding them there because that's the only place your limited spotlight allows you to look? That, in essence, is the core of the observational bias argument against Planet 9. Our telescopes, powerful as they are still just spotlights in an impossibly vast ocean of space. We don't scan the entire sky uniformly or with equal depth. Instead, we tend to focus our surveys on specific regions, often along the ecliptic, the plane where most of the known planets orbit, because that's where we expect to find more objects. And crucially, we mostly detect these incredibly distant, icy objects, known as trans-Neptunian objects, TNOs, when they are closest to the Sun, at a point in their orbit, called perihelion. That's when they're brightest, reflecting just enough sunlight for our instruments to catch a glimpse of their faint glow. Now, think about what happens if you only detect objects when they're at their perihelion. If your telescope is primarily scanning a certain patch of sky, then by definition, the TNOs you do discover will be those whose perihelia fall within that observable patch. And if you're looking at only a small fraction of their incredibly elongated 10,000 to 20,000 year orbits, then it might look like these distant worlds are all pointing their perihelia in the same general direction. It might seem like their orbits are clustered, but the argument goes, this perceived clustering isn't the result of a hidden planet's gravitational tug. It's simply an artifact of how and where we're able to observe them. We're seeing a pattern, but the pattern might be in our looking, not in the cosmos itself. It's a compelling point, isn't it? It forces us to question not just the data, but the very methods we use to gather it. Skeptical scientists point out that the sample size of these extreme TNOs, the ones with the most elongated orbits that extend far beyond Neptune, is still relatively small. While Brown and Batygin initially based their hypothesis on 6 specific objects, and subsequent research has identified more, the total number is still limited. And with a limited sample, even a statistically improbable alignment, like a 1 in 100 chance, isn't entirely impossible. Sometimes the dice just roll that way, but the defense doesn't stop there. Beyond observational bias, some scientists propose alternative explanations for the observed orbital anomalies that don't require a single massive Planet 9. What if, instead of one giant world, the gravitational tug we're seeing comes from something far more diffuse? Imagine a vast, unseen disk of much smaller, icy debris stretching out beyond Neptune. A massive disk of countless little worlds, each too small and faint to detect individually, but whose collective gravity is substantial enough to gently nudge the orbits of the more extreme TNOs. It's like trying to figure out why a field of dandelions is leaning in a certain direction. Is it one giant, invisible fan? Or is it the combined effect of a million tiny air currents? This collective gravity hypothesis suggests that the sum of many small, unseen parts could be creating the illusion of a single massive gravitational shepherd. These aren't just academic quibbles. They are fundamental challenges that strengthen the scientific process itself. The skepticism forces proponents of Planet 9 to refine their models, to seek out new and better data, and to consider every possible alternative. It's a testament to the scientific method. Doubt, challenge, and rigorous testing are not weaknesses. They are the bedrock of true discovery. And this isn't the first time astronomers have found themselves in this exact position. There's a fascinating historical parallel that serves as a powerful cautionary tale: the hunt for the planet Vulcan. Back in the 19th century, astronomers noticed something peculiar about the orbit of Mercury, the innermost planet. It wasn't quite following Newton's laws of gravity. Its perihelion, the point where it was closest to the Sun, seemed to precess or shift by a tiny amount more than could be explained by the gravitational tugs of all the known planets. Based on this discrepancy, a brilliant French mathematician named Urbain Le Verrier proposed that there must be another as yet undiscovered planet, even closer to the Sun than Mercury. He named this hypothetical world Vulcan. For decades, astronomers scoured the skies, especially during solar eclipses, hoping to catch a glimpse of this elusive inner planet. They even reported a few tantalizing but ultimately unconfirmed sightings. It became a compelling century-long ghost hunt, driven by solid mathematical prediction and observable anomalies, but Vulcan was never found. And the reason for Mercury's orbital eccentricity wasn't another planet at all. It was something far more profound. Albert Einstein's theory of general relativity, published in 1915, which fundamentally redefined our understanding of gravity itself. Einstein showed that massive objects like the Sun warp the fabric of space-time, and this warping explained Mercury's peculiar orbit perfectly, without the need for any hidden planet. So, the defense asks, are we hunting a new Neptune, a planet whose existence will soon be confirmed by the telescope? Or are we hunting a new Vulcan, a phantom born from an incomplete understanding of the physics at play, or perhaps from the subtle biases inherent in our observations? It's a question that humbles us, reminding us that even the most compelling evidence can sometimes lead us down a fascinating but ultimately incorrect path. This historical precedent, this awareness of our past blind spots, is precisely why the scientific community is so divided on Planet 9. It's not about animosity or dismissiveness. It's about the deep-seated commitment to intellectual rigor. It's about ensuring that when we finally declare the existence of a new planet in our cosmic backyard, we do so with absolute certainty, having exhausted every alternative explanation, having weighed every piece of evidence, and having stared down every ghost of our own limitations. The courtroom of the cosmos is still in session, and the jury is still out. But the very act of this debate, this intense scrutiny from all sides, is precisely what makes the potential discovery of Planet 9 so incredibly exciting. It means that whatever answer we eventually find, it will be hard-won, rigorously tested, and undeniably true. And the next chapter in this cosmic detective story hinges on gathering even more evidence, with tools more powerful than anything we've had before. Okay, so we've laid out the case for Planet 9's existence. We've seen the breadcrumbs, those bizarrely clustered orbits of distant icy worlds, all pointing their silent, frozen fingers to an unseen giant. We've talked about the brilliant minds, Mike Brown and Konstantin Batygin, who first connected these seemingly random dots into a compelling picture. We've even dipped our toes into the healthy scientific skepticism that keeps everyone honest, demanding absolute proof before we redraw our solar system's map. But here's where the story gets truly wild, because if Planet 9 is out there, if this gravitational ghost is truly haunting our cosmic backyard, then what exactly is it? This isn't just about finding a new dot in the sky. This is about planetary forensics on a scale that boggles the mind. We're talking about taking the subtle whispers of gravity, the way it tugs and pulls on things hundreds of billions of miles away, and using those whispers to paint a portrait of the culprit. Every wobble, every tilt, every stretched-out orbit is a clue, a fingerprint left behind by an invisible hand. And based on these gravitational fingerprints, astronomers have started to sketch out some truly mind-bending possibilities for what this hidden giant could actually be. Each theory isn't just a guess. It's a window into the violent, chaotic, and utterly mysterious past of our solar system, and perhaps even the universe itself. Let's start with the most intuitive, perhaps the most comforting idea. Maybe Planet 9 is just a planet. Not just any planet, though. The evidence suggests it's a super-Earth. Now, if you're like me, you probably think of our solar system as having two main types of planets: rocky, inner worlds like Earth and Mars, and gas giants like Jupiter and Saturn. But out there, in the vast tapestry of our galaxy, super-Earths are actually the most common type of planet known. They are bigger than Earth, but smaller than Neptune, typically weighing in at anywhere from 2 to 10 times our planet's mass. And here's the kicker. We don't have one in our solar system. It's like finding out your family portrait is missing its most common member. So, how could a super-Earth end up so far out in the cosmic boondocks? silently hurting those distant icy worlds. Well, our solar system wasn't always the orderly, clockwork-like place we see today. In its infancy, it was a chaotic mosh pit of gas, dust, and nascent planets. Imagine a cosmic game of billiards, but with objects the size of worlds. It's entirely possible, even probable, that during this turbulent early period, a young super-Earth formed much closer to the Sun, perhaps even in the inner solar system. But then, a gravitational encounter, maybe a close pass with Jupiter or Saturn, or even another protoplanet, could have delivered a slingshot kick so powerful it sent this world hurtling out into the cold, dark reaches of space. Think of it as our solar system's own lost child, ejected from the family home billions of years ago, only to settle into a lonely, distant orbit, still subtly influencing the smaller, more vulnerable residents of the outer darkness. This theory is compelling because it suggests Planet 9 is a missing piece of our own origin story, a cosmic relic that could tell us volumes about how our planetary neighborhood formed and evolved. Finding it wouldn't just be finding a planet. It would be like unearthing an ancient diary, telling tales of our solar system's wild youth. But what if Planet 9 isn't a long-lost sibling, but rather an adopted stranger? This brings us to the second thrilling possibility, that Planet 9 is a rogue planet. Now, rogue planets are exactly what they sound like. Worlds that drift untethered through interstellar space, not bound to any star. They're cosmic wanderers, ejected from their own star systems or perhaps formed in isolation, floating through the galactic void in eternal darkness. We've actually found evidence of such objects out there. Lost worlds without a sun. The idea here is that billions of years ago, as our sun migrated through the dense stellar nursery where it was born, it might have had a close encounter with one of these interstellar nomads. Our sun's immense gravitational pull could have acted like a cosmic lasso, capturing the rogue planet and pulling it into a wide, stable orbit around our own star. It would be a truly incredible cosmic kidnapping, transforming a free-floating world into a distant, adopted member of our solar system. This theory opens up a whole new can of worms, doesn't it? If Planet 9 is a captured rogue, it could be a type of world unlike anything else we've seen in our solar system. It could have formed under wildly different conditions, perhaps around a different star, or in the vast, cold emptiness of interstellar space itself. Studying it would be like getting a direct sample of another star system, or even a glimpse into the fundamental processes of planet formation in the deepest corners of the galaxy. It would transform the search from a local family reunion into an intergalactic detective story. Imagine that, a world in our own backyard that originated light years away. The mind reels, but hold on to your hats, because we're about to dive into the most exotic, the most mind-bending, and frankly, the most bizarre possibility of them all. What if Planet 9 isn't a planet at all? What if it's something far stranger, something that stretches our understanding of reality and physics? What if Planet 9 is a primordial black hole? Yes, you heard that right, a black hole. Now, when you think of a black hole, you probably picture those cosmic monsters, millions or even billions of times the mass of our sun, devouring everything in their path. But primordial black holes are different. The theory goes that these tiny ancient black holes weren't formed from the collapse of massive stars. Instead, they're relics from the very dawn of time, born in the incredibly dense, chaotic moments right after the Big Bang. And here's the kicker. Some scientists propose that a primordial black hole with the mass of Planet 9, about 5 to 10 times the mass of Earth, would be incredibly small. We're talking about something no bigger than a grapefruit, or even a bowling ball. Imagine that, a cosmic entity with the gravitational pull of 10 Earths, yet physically smaller than you could hold in your hands, silently influencing the outer reaches of our solar system. It's almost too wild to contemplate. Such an object would be virtually invisible. It wouldn't reflect light because it's a black hole. It wouldn't emit much heat. So how on earth would we find something like that? Well, the search would shift dramatically. We wouldn't be looking for reflected sunlight. Instead, astronomers might look for the subtle warping of space-time around it, a phenomenon known as gravitational lensing. As light from distant stars passes by this tiny, dense object, its path would be ever so slightly bent, creating a distorted image that telescopes could potentially detect, or even more exotically. If this primordial black hole happens to interact with dark matter particles, it could theoretically produce bursts of gamma rays, a faint signal that advanced instruments might pick up. This theory is definitely on the fringes, but it's not entirely dismissed. It takes the search for Planet 9, from a quest for a missing world, to a hunt for a fundamental, exotic piece of the universe itself. It would rewrite our understanding of our solar system's composition and potentially provide direct evidence for one of the most enigmatic predictions of Big Bang cosmology. Talk about raising the stakes. So, whether it's a super-Earth, a captured rogue, or primordial black hole, the implications are enormous. Each of these theories paints a different picture of the suspect, and each one transforms the stakes of our cosmic detective story. This isn't just about adding a ninth circle to our planetary diagram. It's about potentially uncovering a key to our solar system's violent past, a window into interstellar planet formation, or even a relic from the very genesis of the universe. The hunt continues, with astronomers using the most powerful telescopes on Earth, like the Subaru telescope in Hawaii and the Vera C. Rubin Observatory in Chile, which is set to begin its full science operations in 2025. The Rubin Observatory, with its massive 8.4-meter mirror and a 3.2 gigapixel camera, will systematically survey the entire southern sky every few nights, creating an unprecedented map of our cosmic neighborhood. Its sheer power and relentless scanning ability make it the most promising tool we have to either finally spot Planet 9, whatever its true nature may be, or definitively rule out its existence. The prospect of finding a super-Earth, a long-lost cousin, would be a monumental discovery, confirming that our solar system, like so many others, once harbored these common giants. The revelation of a captured rogue planet would force us to redefine what ours truly means in the cosmic sense, reminding us that even our most distant worlds might have traveled across the galaxy to join us. And the discovery of a primordial black hole, well, that would be a paradigm shift, pushing the boundaries of astrophysics and cosmology in ways we can barely imagine. What makes this search so exhilarating is that we're not just looking for a new planet. We're looking for an answer to a profound question about our place in the cosmos. Is our solar system truly unique, or does it hold secrets that reflect the broader cosmic narrative? The very act of peering into the vast, dark emptiness, driven by the subtle gravitational whispers, is a testament to human curiosity and our insatiable desire to understand the universe around us. The scientific community is buzzing with anticipation. The mathematical models are robust, the orbital anomalies are compelling, and the tools to find it are finally coming online. The probability of those 6 distant TNOs having their orbits clustered so precisely by chance is astronomically low, about 1 in 100, or 0.07%. This isn't just a hunch. It's a powerful statistical argument for something massive out there. And the hypothesis doesn't just explain those initial 6 objects. It also predicted the existence of other objects with perpendicular orbits And astronomers have found those too, further bolstering the case. The estimated mass of Planet 9, between 5 and 10 Earth masses, and its incredibly long orbital period of 10,000 to 20,000 years, mean it's been lurking in the shadows for eons, a silent observer of our solar system's history. Its average distance from the Sun, ranging from 400 to 800 AU, explains why it has remained so elusive. It's estimated to be around 5,000 times more massive than Pluto, making it undeniably a true planet. By any definition, this isn't just a modern mystery. The history of astronomy is filled with predictions of unseen worlds. The discovery of Neptune in 1846, for example, was a triumph of mathematical prediction. Astronomers noticed strange perturbations in Uranus's orbit and deduced that an unseen planet must be tugging on it. Urbain Le Verrier and John Couch Adams independently calculated its position, and when telescopes were pointed to that precise spot, there it was, Neptune. That historical precedent gives us hope, a powerful reminder that sometimes the ghost in the machine is real. But we also remember the hunt for Vulcan in the 19th century, a hypothetical planet inside Mercury's orbit, also predicted by orbital anomalies. That phantom turned out to be an illusion. The anomalies later explained by Einstein's theory of general relativity. So, are we hunting a new Neptune or a new Vulcan? The tension between these historical precedents fuels the current debate and makes the search for Planet 9 even more compelling. No matter what Planet 9 turns out to be, or not to be, the journey itself is unraveling profound truths about the universe. It's showing us how interconnected everything is, how the smallest wobble in a distant icy world can hint at the presence of a behemoth. It's demonstrating the incredible power of human intellect, using math and observation to peer into the invisible. And it's reminding us that even in our own cosmic backyard, there are still vast, uncharted territories waiting to reveal their secrets. The very idea that a world 10 times the mass of Earth could be lurking unseen, just beyond our current knowledge, is both humbling and incredibly exciting. It means our map of the solar system is incomplete. It means there are still fundamental discoveries to be made right here, at home. And when the Vera C. Rubin Observatory begins its systematic scan, the universe will hold its breath. Will we finally unmask this gravitational ghost? Or will the mystery deepen, forcing us to rethink everything we thought we knew? The answer, friends, is closer than ever before. The answer, friends, is closer than ever before. But to truly appreciate the hunt for this ghost, to grasp the sheer audacity of its potential existence, we first have to ask, where did it come from? How could such a colossal world remain hidden? A whisper of creation, echoing through the vastness of our own cosmic backyard. To answer that, we have to journey back, way, way back. Imagine the universe not as a static canvas, but a swirling, breathing entity. Picture the earliest moments, not of our solar system, but of the cosmos itself. Vast, dark fields of hydrogen and helium, the raw ingredients of everything we know, drifting in an ancient, silent ballet. Then, something shifts. A ripple in the cosmic fabric. Perhaps a passing supernova. Perhaps just the relentless pull of gravity beginning its eternal work. Giant clouds of gas and dust, stretching light years across, begin their slow, majestic collapse. These are the nebulae, the stellar nurseries where stars are born. We see them today, vibrant and colorful, through our most powerful telescopes, pillars of creation, the Orion Nebula. But imagine them forming not as distant art, but as the fiery, churning crucible of creation. They tighten, they spin, they heat up, and at their hearts, new suns ignite, blazing forth to pierce the primordial darkness. Our own sun was born this way nearly 5 billion years ago. Not alone, but amidst a swirling, chaotic disk of leftover material, dust, ice, gas, all orbiting that newborn star. This was our protoplanetary disk, the fertile ground from which all the worlds we know would eventually emerge. It was a place of immense beauty and incredible violence. Tiny particles collided, stuck together, grew. Pebbles became rocks, rocks became boulders, boulders became planetesimals, and these planetesimals, in turn, began to clear their paths, sweeping up material, growing ever larger, ever more massive. This is the standard story, the elegant dance of accretion that gave us Mercury, Venus, Earth, Mars, and the gas giants, Jupiter, Saturn, Uranus, and Neptune, each finding its stable orbit, settling into a gravitational rhythm. But what if, in that frenzied adolescence of our solar system, something didn't quite settle? What if, in the gravitational jostling and sweeping, a world got a push, a nudge, a violent kick that sent it spiraling out, far beyond the comfortable neighborhood of its siblings? This is one of the leading theories for our elusive Planet 9, that it's a super-Earth, a type of planet far more massive than our own, yet smaller than the ice giants like Neptune. These super-Earths are, in fact, the most common type of planet we find around other stars across the galaxy. Yet, conspicuously, we don't have one in our own inner solar system. What if we did? What if one formed here, a beefy, icy giant, only to be gravitationally bullied by the likes of Jupiter or Saturn, flung out into the frigid, lonely dark? Imagine the sheer force required. A dance of giants, a cosmic game of billiards, where one massive ball slams into another, sending it careening off the table, out into the vast, empty stadium of interstellar space. It wouldn't be a gentle drift. It would be a violent expulsion, a planetary exile. This super-Earth, now a lonely wanderer, would then slowly, over eons, settle into that incredibly distant, elongated orbit we now infer, still tethered to our sun, but barely. Its years would stretch into millennia, its path a silent, solitary journey through the deep freeze. But that's not the only tale the whispers of creation might tell. What if Planet 9 wasn't born in our solar system at all? The universe is full of rogue planets, worlds that didn't win the gravitational lottery, worlds that formed around other stars, or perhaps even in the vast interstellar voids, and were then violently ejected, set adrift, untethered to any sun. They float through the galaxy, dark and cold, true cosmic orphans. Think about it, billions upon billions of stars, each with the potential for its own planetary system. And in the chaotic process of star and planet formation, many worlds get cast out. They drift, aimlessly, through the interstellar medium, sometimes for billions of years. Could our sun, sailing through the Milky Way, have passed close enough to one of these interstellar nomads, its immense gravity reaching out and snaring it, slowly pulling it into a new, incredibly wide orbit? This idea that Planet 9 could be a captured rogue planet adds another layer of profound mystery. It would mean our solar system isn't just a closed family unit. It's a cosmic melting pot, occasionally adopting a wanderer from the galactic depths. Such a world would carry the secrets of another star system, another birth, another journey. Now, a silent, icy sentinel guarding the outermost reaches of our adopted home. It would be a tangible link to the broader universe, a piece of something alien, yet now undeniably ours. And then there's the truly mind-bending possibility, the one that pushes the boundaries of our imagination to their absolute limit. What if Planet 9 isn't a planet at all, in the traditional sense, What if it's something far more exotic? Something born in the very first moments after the Big Bang itself? What if it's a primordial black hole? Don't let the words black hole conjure images of galactic devourers. A primordial black hole wouldn't be a stellar collapse remnant. It would be a tiny ancient singularity formed from the immense pressures and density fluctuations of the early universe. Imagine a black hole with the mass of 10 Earths, yet compressed to the size of a grapefruit or even a bowling ball. Such an object would be invisible, radiating no light, reflecting no light, detectable only by its immense gravitational pull. Its presence would perfectly explain the orbital clustering of those distant icy worlds. Its gravitational footprint would be exactly what Mike Brown and Konstantin Batygin have modeled. It would be the ultimate ghost, a dark, silent sentinel whose very existence warps the fabric of space-time itself, subtly influencing everything around it without ever revealing itself directly. This isn't just a hunt for a planet. It's a search for the deepest secrets of cosmic physics, a potential glimpse into the very infancy of the universe. As we visualize these abstract cosmic forces at play, nebulae collapsing, protoplanetary disks forming in a violent ballet, rogue planets drifting through the interstellar medium, and the subtle, invisible warping of space-time, we begin to grasp the profound timescales and the chaotic majesty that could have birthed such a hidden giant. The universe, in its raw, untamed youth, was a place of immense creation and destruction, where worlds were made and unmade, scattered and captured. Whatever Planet 9 truly is, an ejected super-Earth, a captured interstellar wanderer, or even a primordial black hole, its existence speaks to the dynamic, often unpredictable nature of our cosmos. It tells a story of deep time, of forces beyond our everyday comprehension, shaping worlds over billions of years. It's a story whispered across the light years, a silent symphony of gravity and chance, waiting for us to finally hear it, to finally see the face of the hidden giant. The breadcrumbs have been laid. The mystery has been posed. Now, the hunt truly begins. The breadcrumbs have been laid. The mystery has been posed. Now, the hunt truly begins. But this isn't some quick jaunt into the nearest woods. This is a journey into the deepest, darkest corners of our own cosmic backyard, a place where the sunlight barely whispers and the cold is absolute. It's a hunt for a ghost, a titan whose gravitational shadow stretches across hundreds of billions of miles. Finding Planet 9 is an undertaking of truly staggering proportions. Imagine a world 5 to 10 times the mass of Earth, but so far away, potentially 400 to 800 times farther from the sun than we are, that it reflects almost no light back to us. It's like searching for a single unlit matchbox in a pitch-black stadium the size of a continent. Even if it were as bright as Neptune, Planet 9 would be 160,000 times dimmer to our eyes. The cold means it barely radiates any heat, making it almost invisible, even to our most sensitive infrared detectors. It's a silent, frozen phantom, circling our sun, once every 10,000 to 20,000 years, a celestial elder whose presence is only revealed by the subtle, almost imperceptible way it nudges its smaller, icy neighbors. For years, the search has been a painstaking, almost agonizing process. Astronomers around the globe, armed with the most powerful telescopes ever built, have been scanning vast swathes of the sky, looking for the faintest pinprick of light that moves. But the sheer volume of space is overwhelming, and the target is maddeningly elusive. Every observation is a triumph of engineering and human persistence, yet the void often gives back nothing but more void. It's a testament to the scientific method, the unwavering belief that if the evidence points to something, eventually you will find it. And now, We stand on the precipice of a new era in this grand cosmic detective story. The game is about to change. Enter the Vera C. Rubin Observatory, a colossal eye on the sky, perched high in the Chilean Andes. This isn't just another telescope. It's a revolutionary instrument, a true hero in our unfolding narrative. Expected to begin its full science operations in 2025, the Rubin Observatory is designed to do one thing better than anything before it: survey the entire southern sky every few nights. Its massive 8.4-meter primary mirror and a 3.2 gigapixel camera, the largest digital camera ever built for astronomy, will allow it to capture the most comprehensive, deepest, and fastest scanned astronomical images in history. Think about that for a moment. Every few nights, a complete picture of the southern sky. Updated, refreshed, meticulously catalogued. What does this mean for our hunt? It means that if Planet 9 is out there, moving slowly against the backdrop of distant stars, the Rubin Observatory will see it. It will detect that tiny, almost imperceptible shift, that ghost-like movement that betrays its presence. It's not a question of if it can find it, but when. Within a year or two of its launch, this observatory is poised to either confirm the existence of Planet 9 or perhaps definitively rule it out. We are living in a unique moment, a true crossroads in our understanding of our own planetary neighborhood. This isn't the first time humanity has found itself at such a crossroads, staring into the unknown reaches of our solar system. The history of planetary discovery is littered with both triumphs and tantalizing phantoms. Consider the discovery of Neptune in 1846. It wasn't found by chance. It was found because the planet Uranus wasn't behaving as it should. Its orbit was off, perturbed by something unseen. Urbain Le Verrier and John Couch Adams, two brilliant mathematicians, independently crunched the numbers, predicted the unseen culprit's location, and astronomers pointed their telescopes exactly where they were told. And there it was, Neptune, a magnificent blue giant, waiting patiently in the dark, its existence confirmed not by sight first, but by the subtle tug of its gravity. It was a monumental achievement, a testament to the power of human intellect and the elegance of physical laws. But then there's the cautionary tale of Vulcan. For decades in the 19th century, astronomers believed there was another planet, Vulcan, orbiting inside Mercury's orbit. Mercury's path around the Sun was also a little off, not quite matching Newton's predictions. Many spent years searching for Vulcan, convinced it was real, a hidden world closer to our star. But Vulcan was a phantom, an illusion. The anomaly in Mercury's orbit wasn't caused by another planet. It was caused by something far more profound: the curvature of space-time itself, a phenomenon later explained by Albert Einstein's theory of general relativity. The universe, it turned out, was stranger and more beautiful than Newton had ever imagined. So, as we stand here today, gazing metaphorically at the edge of our solar system's map, we must ask ourselves, are we on the verge of discovering a new Neptune, confirming our understanding of gravitational mechanics, or are we hunting a new Vulcan, an unseen anomaly that will force us to confront an even deeper mystery, perhaps even a new physics? Ancient maps, when they depicted the unknown, the terrifying, the edges of the world where knowledge faded into speculation, would sometimes bear the chilling inscription, "Here be dragons." It was a warning, a myth, a placeholder for the vast, untamed wilderness beyond the familiar. We are now standing at the very edge of our solar system's map, peering into that same kind of unknown. The dragons that might reside there aren't fire-breathing beasts, but something perhaps even more awe-inspiring. A colossal hidden world, a super-Earth, or a captured rogue planet, a relic from the early chaotic days of our cosmos. Or perhaps something even wilder, like a primordial black hole, a tiny dense seed of creation from the universe's infancy, quietly shepherding icy worlds with its immense invisible gravity. The implications of finding Planet 9 are staggering. It would fundamentally rewrite our textbooks, expand our understanding of how planetary systems form and evolve, and confirm that even our own familiar home still holds profound secrets. It would be a triumph for the precise, elegant models of gravitational clustering that Mike Brown and Konstantin Batygin meticulously constructed, a cosmic validation of their eureka moment. It would be a testament to the human spirit of exploration, pushing the boundaries of what we thought we knew about our own cosmic address. But what if the Rubin Observatory scans the sky night after night for years and finds nothing? What if, despite all the evidence, all the mathematical models, all the persistent orbital anomalies, Planet 9 simply isn't there? That, in its own way, would be an even more profound discovery. If we meticulously search every corner of the predicted zone and come up empty, it wouldn't mean the orbital anomalies magically disappear. It would mean our current understanding of gravity, of planetary dynamics, of the very fabric of our solar system is incomplete. It would force us to confront the possibility that the universe is even stranger than our wildest predictions, that there's an undiscovered law of physics at play, a new cosmic force, or an entirely different kind of unseen structure that we haven't even begun to imagine. It would be a paradigm shift, an invitation to a deeper, more challenging mystery that could reshape astronomy for generations. Which discovery would be more profound for you? Finding Planet 9 exactly as predicted, confirming our models of the universe, and solidifying our understanding of how worlds are made. Or finding nothing, forcing us to admit that our maps are still incomplete, and that the universe holds secrets so deep they demand an entirely new way of thinking. What does the nature of discovery itself mean to you? Is it about confirming what we suspect, or shattering our preconceived notions and opening the door to the truly unknown? We are on the cusp of an answer, standing at the edge of the map, ready to see if the dragon is real. The hunt is on, and the universe is waiting. If you've been as captivated by this cosmic detective story as we have, make sure to hit that subscribe button. Join the Celestial Enigmas family, and let's keep exploring the wonders and mysteries of the universe together. You won't want to miss what we find next.